Hello student, welcome to the lecture of Power System 1. So today we will discuss tuned power lines. So the basic definition of tuned power line is when the receiving end voltage and receiving end current both are numerically equal to the sending end value so that there is a no voltage drop on load. Such a line is called as tuned power line. So first of all, we should come to the basic equation for a long transmission line which we have already derived. In this, we had these equations whereas gamma is equal, which is a propagation constant, which is given as square root of yz. Now y is given as G plus JB and Z is given as R plus JX. But long transmission line has negligible resistance as compared to the inductance, and in long transmission line G, that is a conductance, is very negligible as compared to the susceptance. So we can have this equation, that is propagation constant equals to j omega under root LC. So this cos h gamma L equals to cos h j omega L under root LC, which can be written as cos omega L under root LC. Similarly, sin h gamma L is equals to j sin omega L under root LC. So the new modified matrix comes to be like this. Now, as per our basic equation, that is Vs equals to, for tuned power line, Vs should be equals to Vr and Is should be equals to Ir. So for this purpose, this cos omega L under root Lc should be equals to 1 and this should be equals to 0. Similarly, this should be equals to 0 and this should be equals to 1 in order to get this equation Vs equals to Vr, Is equals to Ir. So this cos omega Lc will be 1 only when the value of omega L under root Lc equals to n pi. So our equation comes like this: L equals to n pi upon 2 pi f under root LC. So we are finding the length of line for tuning the transmission line. So for 50 hertz, this equation comes n by 100 upon 1 upon under root LC, where n is numerical number which goes from 1 to 3 to so on, whereas 1 upon under root LC is a v, which is a velocity of light. So v is rather given as 3 into 10 raised to 5 km per second. N is equals to n by 100 into 3 into 10 raised to 5 kilometers. So the line length for tuned power lines we get is 3000 kilometers, 6000 kilometers, 12,000 kilometers, so on. So practically it is not able to we are not able to achieve the tuned power line because distance required is very long. So this is not possible. So how we can achieve the tuned power line? By adding inductance and capacitance. So one of the method is having series inductance for light load, and for heavy load you should have shunt capacitors in order to neutralize the impact of capacitance during a light load, and at a heavy load we need to neutralize the effect of inductance. So this is a rather impractical and uneconomical method. So we have another method which is called as compensating sections, in which we will have C dash and L dash. C dash is capacitance connected in series and L dash is inductance connected in shunt. So C dash will neutralize the C dash and L dash are so calculated that C dash series capacitance will neutralize the effect of inductance in impedance Z, whereas I dash will neutralize the effect of capacitance in a shunt branch, so that virtually there will be no voltage drop. So tune power lines ends here. Thanks for watching.